Hi, future doctors. Welcome to the next class. So, we were discussing about magnetism and matter. So, we stopped at magnetic field. So, if two magnets are placed at two opposite corners of a square of each side is going to be small a. So, South Pole, North Pole. Here, poles are going to be very important. So, South Pole, North Pole. So, two magnets of same magnetic moment. Magnetic moment direction south to north. What is the resultant magnetic field at remaining corner? Either this corner or this corner they are going to ask. So this is point P. So this point P is which line for this first magnet, second magnet. So point P is axial line. So on axial line, what is the direction of magnetic field? In the direction of south to north. Therefore, towards left side. This is B1 you can assume. Next, for the second magnet, this is which point means equatorial line. Equatorial line at a distance A. In which direction resultant magnetic field? Opposite to south to north. Therefore, right side B2. So B1 is left side, B2 is right side. What is the resultant magnetic field? At point P means B1 minus B2. What is B1? Mu naught by 4 pi 2 m by A cube minus mu naught by 4 pi m by A cube. Otherwise, this one we will write k. 2 km by A cube minus km by A cube. 2 minus 1. Final answer is km by A cube. That resultant direction will be towards left. Isn't it? Now, same question. If they interchange the poles here, if it is north pole, if it is south pole, then resultant magnetic moment will be like this. Then B2 will be like this. Correct? Then you have to add B1 and B2. So this is B1, this is B2. At that time, your answer is BP is equal to plus you will get here. So 3 km by AQ. You should see very clearly. So this is one model on magnetic field. Next one is time period of the magnet. So time period magnet formula 2 pi root I by m b. If magnet is cut, parallel to its length, then time period remains same, t dash equal to t. But if magnet is cut perpendicular to its length into n parts, so if it is divided in parts, we have discussed already, t dash is t by n. Very important model. Next, so if two magnets by touching same poles, north pole, south pole, two magnets of magnetic moments m1, m2, I1, I2. Then time period is going to be T1 is equal to 2 pi root I1 plus I2 by same direction means m1 plus m2 into B. So opposite poles touching each other, north pole, south pole, north pole. So m1, m2. At the time T2 is going to be I1, I2. So same 2 pi root I1 plus I2 by m1 minus m2 into B. Correct? Next. So they will ask what is the ratio of magnetic moments. Already we derived this in our normal videos. You can see if you want. Here I am giving directly T2 square plus T1 square by T2 square minus T1 square. You don't need to worry about T1 square minus T2 square or T2 square minus T1 square. Negative time you won't get. Okay. Next, in this, if same magnetic moment is placed, so m minus m is 0, then time period is going to be infinity. Correct? In that case, sometimes they will give a magnet of magnetic moment m, a wood is placed. A wood is placed means there is no north pole, south pole. So same mass they will give. At the time, moment of inertia will be changing. M and B will not change. At the time, new time period 2 pi root 2I by mb. So this is going to be wood. Wood of same mass. Then moment of inertia will be added. T dash is going to be 2 pi root I by mb. We can write it as 2 root 2 t. are going to get. If similar mass, similar size having wood in place of second magnet. Like that, if they give two wooden blocks, so I plus I plus I, root 3 times. So this is about time period. So by using calculating all these values, we are going to get the answer. Calculations are going to be very important. What is capital M here? Magnetic moment, pole strength into 2A. So last year, 2024, they asked a problem in both the exams, cancelled exam and reconducted exam and main exam on this equation. With the same diagram, if you observe, we are going to get. For those, calculations are going to be playing main role. Next, so this magnet is placed in uniform magnetic field. It is going to make oscillations. The amount of work done or torque acting on that short magnet. Torque formula, tau bar is equal to, in electric field, P bar cross E bar. In magnetic field, M bar cross B bar. This one only, MB sin theta. If theta is 0 means in which direction magnetic field is there? In the direction magnetic moment also there. Magnetic moment there. Or opposite direction. If theta is 0, 180, torque is going to become 0. If theta is 90, torque is going to become MB. Torque is going to become maximum if theta is going to be 90. The amount of work done to rotate dipole, work done formula, so MB cos theta 1 minus cos theta 2. So in electric field, you will get here PE cos theta 1 minus cos theta 2. In 2025, they asked a question on this equation, but in electric field, PE theta 1 theta 2 they gave, isn't it? So what is the work done to rotate magnet from 90 degrees to theta 1 is equal to 90 degrees, that is pi by 2 to theta 2 is going to be theta, will be stored as potential energy. So that case U is equal to MB cos 90 0 minus cos theta. So MB minus cos theta, this one only they will write M bar dot B bar with negative sign. So this is the potential energy M bar dot B bar. Potential energy of the magnetic moment in uniform magnetic field to rotate from theta by 2 to theta. So while using this formula, stable and unstable equilibrium, if theta is 0, it is called stable. If theta is 180 degrees, that is called unstable. So 0 to 180. They will give what is the work done to rotate a magnet from stable to unstable position, means 0 to 180 degrees. Then theta 1 should be 0. Cos 0 value 1. Cos 180 minus 1. Then you will get cos 0 1 minus of minus 1 plus 1. 1 plus 1 2. 2 MB you will get. Stable to unstable. Unstable to stable. Unstable to stable means minus 2 MB you will get. That one you should see very clearly whatever they are going to ask. If theta is 0, that is in stable position. If theta is 0, this value is going to be minus MB. If theta is 180, cos 180 minus 1, minus or minus plus. So plus MB is the potential energy for unstable position. Minus MB is for stable position. Potential energy. Next, on this, how they may ask the questions. So potential energy or work done they will give to rotate the short magnetic moment from stable to unstable. That is going to be 2 MB. So 2 MB is going to be 10 joules. Whenever short bar magnet is rotated from stable to unstable, 10 joules. Then what is the torque acting at theta is going to be 60 degrees. Torque acting at 60 degrees means torque formula MB sin theta. So at 60 degrees they are asked what is the how much torque to rotate for 60 degrees they are going to ask. At the time MB value how much from this means, from this MB is going to be 5, correct? This 5 we are going to use 5 sin 60. What is sin 60 value? Root 3 by 2. Therefore root 3 into 5 by 2. Otherwise 2.5 root 3 Newton meter. So like this they will ask. Otherwise, they will give how much maximum torque is acting, they will ask for the same question. So what is the maximum torque formula? So already this one they gave, it is rotated from stable to unstable. So tau maximum formula is MB. What is MB from this? 2 MB is 10 joules. Then MB is going to be 5 Newton meter. So they may ask anything. Just once you know the formula, you can play with that formula, isn't it? Otherwise, formula is going to play with you people. So this is about time period, potential energy, and magnetic field relations. So magnetic field still they may ask if they place two magnets like this, south to north, so another magnet like this, south to north. So this is M. Yeah. So what is the magnetic field at center of these two? Small r, small r. So we require only directions. So on axial line, it will be in the direction of magnetic field. This is 1 and 2 you can assume. So B1 in the direction of south north. So this is also B2 in the direction of south north. So B1, B2 axial lines. Therefore, resultant at point P is going to be B1 plus B2. So 2 km by r cube plus 2 km by r cube. So 4 km by r cube. If they interchange these poles, so this is south pole, north pole, then direction is reversed. B2 will be like this. At that time, resultant will become 0. So already we discussed this in our 10 minutes or 15 minutes videos. You can go and cross check. So you will become perfect on this, isn't it? So this is about magnetic field. Now we'll see relations between so B, H and I. In this, solenoid will be there. So in solenoid, what is meant by solenoid we said? So a cylindrical, empty cylindrical, hollow cylindrical, non-magnetic material is going to be wounded by wires. So one will be acting as south pole, another one will be acting as a north pole. In this, if you send I current, so you are getting confusing with capital I and small capital I. Here current means small I you can write. Here I is going to be current. What is the magnetic field at center of solenoid means? B is equal to mu naught N I. So if you place one ferromagnetic material, iron, if you place within this solenoid, this magnetic material, ferromagnetic material is going to become magnet. So after some amount of time, it is going to become magnet. So the magnetic field produced due to this current is going to make this magnetic material as a magnet. Therefore, this one we are calling it as magnetizing field, H. So if a magnetic material is converting into a magnet, that H or magnetic field we are calling it as magnetizing field. Magnetizing field. Who will produce magnetic field means magnet will produce magnetic field. So this is called magnetic field induction. So many names will be there. So magnetic field induction and magnetic flux density. Magnetic flux density, that is also name of this capital B. Magnetic field also we will call. So what is this I? Intensity of magnetization. Intensity of magnetization. So this will be depending on how fastly that magnetic material is going to become magnet. If this is magnetic material means, so in this each magnetic moment will be there in their own directions. Like in classroom, students will be there without sir or without faculty. So after coming faculty, all the students are turning into one particular direction. If magnetic material is going to become as a magnet whenever all magnetic moments aligned in one particular direction. The field which is making this magnetic material to convert as a magnet, that field we are calling it as magnetizing field. In solenoid, current is going to be producing, therefore B is equal to mu naught H. If you compare, H is going to be N I. Okay. If you are taking magnet, it will be having south pole, north pole. So if you brought one iron needle here, so this iron needle can attract another small iron needle for some time. So this is, it is going to remember its magnetism property sometime. So that is called retentivity. To remove this magnet by dropping, by hammering, By heating, we can remove the magnetism. By dropping this iron, it is going to lose its magnetism property. That is called coercivity. So retentivity means it is remembering. Coercivity means whichever is going to be remembered, we eliminate it. So that coercivity they are going to give, call it as H. That retentivity they will give as B. At the time you have to use this formula. Coercivity they will give what is the current they will ask. What is small n means here? Number of turns per unit length. On the solenoid, how many number of turns are there per unit length? Next term. So what is I here? So whenever we are magnetic metal is getting magnetized. So within this volume, each volume is going to be converting as magnet. Then total volume is going to be converting as a magnet. Intensity is going to be defined as magnetic moment aligned per unit volume. Otherwise, pole strength into 2A divided by area into length. So pole strength per unit area M by A. So what is magnetic moment units? Ampere meter square. Volume units meter cube. Therefore, intensity of magnetization units is ampere per meter. Isn't it? So this is going to be I. This I is M by V. Next, susceptibility. What is susceptibility means? The ratio of intensity of magnetization and magnetizing field. Psi is equal to I by H. I is equal to psi H they are going to write. Next, we wrote B is equal to mu naught H in the vacuum. In medium or B naught you can write. B naught equal to mu naught H. In medium, B is going to be mu H. So this mu can be written as mu R is equal to mu by mu naught. Mu is equal to mu naught into mu R. That mu we can write here mu naught mu R H. Again, mu R can be written as in terms of susceptibility. Mu R is 1 plus psi. Therefore, B is equal to mu naught into 1 plus psi H. So, whenever in vacuum is going to be converting into medium, what is the fractional change in the magnetic field they will ask. What is the fractional change in formula means? Delta B by B. That is nothing but B minus B naught by B naught. Percentage if they ask means into 100 they will do. So, what is B here? So, what is B here means? In medium, mu naught into 1 plus I into H minus what is B naught means? Mu naught H divided by mu naught H. This is fractional change in magnetic field. So, mu naught H plus mu naught xi H minus mu naught H divided by mu naught H. So, these two will be cancelled. So, mu naught xi H by mu naught H. So, these two will be cancelled. So, simply you should remember susceptibility into 100 gives so percentage change in magnetic field. So, whenever we are placing here vacuum is there initially, then V naught is equal to mu naught H. So, whenever you are placing one magnetic material, so in that it is going to become new magnetic field mu naught into 1 plus psi H. So, what is the fractional change in? So, they will give simply susceptibility into 100. Susceptibility will not have any units because that is dimension less quantity, isn't it? All these already we have given previously comparisons for electric field and magnetic field. You can watch those. You can get just here we are giving some more information in less amount of time. Next, this susceptibility will be how it is going to be varying for diamagnetic material, paramagnetic material, ferromagnetic material. Diamagnetic material means which is going to be repelled by magnets slowly. Paramagnetic material means feebly it is going to be attracted. Ferromagnetic material means strongly it is going to be attracted. So, this susceptibility value is negative. It does not depend on temperature. Does not depend on temperature. Therefore, whenever they are asking graph like this for diamagnetic material, so they will give like this constant and a negative psi value does not depend. So, for paramagnetic material, susceptibility Curie's law is inversely proportional to absolute temperature. How they will give graph means susceptibility and temperature for paramagnetic material, inversely proportional rectangular hyperbola. This is for paramagnetic material. For ferromagnetic material, so up to some amount of temperature, susceptibility does not depend on temperature, but still if you are increasing means what it will do means at one particular temperature, if T is equal to Tc, Curie's temperature, ferromagnetic material will become paramagnetic material. So at what temperature ferro became para, that temperature we are calling it as Curie's temperature. Above Curie's temperature, susceptibility will be varying like this. So this is going to be curve we are going to get. Or in some books they are going to give like this also. So above Curie's temperature, this is Curie's temperature, it is going to be inversely proportional. Okay, this is psi and absolute temperature. So here we are concentrating more on how to solve the problem, isn't it? So coercivity they will give, what is the current they will ask, number of turns per unit length they will give. Coercivity. Coercivity means demagnetization for a magnet which is going to be acting as a magnet. Demagnetization of a magnet is nothing but coercivity. That magnetic field intensity they are going to give, intensity of magnetizing field, at that time current they will ask in the solenoid. So here these relations you have to remember carefully, then you can solve the problems. Here mu r is going to be, equal to 1 plus psi. This one you will get in electricity also, epsilon r is epsilon by epsilon naught. Here mu by mu naught we are going to get, isn't it? So this information may help for you people to revise quickly, but so this is going to be equal to temporary. If you are using shorthand, if you are writing exam means, that is like tent house we are making for one day preparation. Later you may forget this. So if you remember, if you practice very well, so slowly, steadily, then that one only you can remember. But it will also be helpful for some students. Thank you.